Alright guys, so today we're doing the power reducing and half angle formulas. So here are our power reduction formulas of sine squared and cosine squared. The first example, we're going to rewrite sine squared times cosine squared as a sum or difference. So in the end, we want adding and subtracting, and we want it to be in cosine. So the first thing I'm going to do is actually use the reduction formulas right here. So sine squared is 1 minus cosine 2 theta. So that's double, right? All over 2 times 1 plus cosine 2 theta all over 2. If we multiply this out, we get 1 minus cosine squared 2 theta all over 4. Again, we want to have cosine to the first power, so we have to do more here. What I'm going to do first is separate this. So we have 1/4 minus 1/4 cosine squared 2 theta. Okay, because we have one denominator that we can split to both. Next, we have another power right here, cosine squared. So we can do the same thing again here. I keep the 1/4 minus, I'm going to put the 1/4 out with parentheses, and I'm now going to do this power reduction formula. So 1 plus cosine 2 theta, but our theta in this case is another 2 theta, so we gotta keep them both in there, all over 2. Now we are not done yet because we have a multiplication here. We want everything for sum and difference. So I'm going to distribute that 1/4 out. Our final answer being 1/4. So here I have 1/2. Negative 1/4 times 1/2 is negative 1/8. Then I have 1/2 cosine here times, or 1/2 cosine here times negative 1/8 is negative 1/4 is negative 1/8 cosine of 4 theta. And we're done. Okay, down below here we have our half angle formulas. Example 2 says use the half angle formula to find the exact value of 15. So what angle on our unit circle, if we cut in half, gives us 15? Well, that would be 30. So we can change cosine 15 to 30 over 2. What I want you to recognize also is that cosine of 15 degrees is in quadrant 1. So now I'm going to use my half angle. Because it's in quadrant 1, we don't need to have the minus. We just need the plus, because cosine in quadrant 1 is positive. So 1 plus cosine, and then it's theta, so in this case it's 30 over 2. So let's start plugging away here. So that's 1 plus, well, cosine of 30 is the square root of 3 over 2 all over 2. And if you want to keep going with this to simplify it more, I'm going to multiply all terms by 2 to get rid of this So if I multiply this by 2, we get square root of 2 plus square root of 3 all over 4. Now be careful how you're writing, because that 4 is still under the square root. So we can then write this as the square root of 2 plus square root of 3 all over, because what's the square root of 4 is 2. Couple more examples and then we are done, guys. So next I want you to see in example 3 that this is negative pi to 0. So in our unit circle, that would be the lower half of our unit circle. And in the lower half, because we're finding sine, we have sine is negative. We know that cosine theta is negative 3 over 5, and we're finding sine theta over 2. So sine theta over 2. Go back to your formula sheet. We're gonna do the negative, because it's negative. We're in that quadrant. 1 minus cosine theta all over 2. Then we replace what was given to us. So 1 minus negative 3/5 all over 2. And we keep simplifying. So I get negative square root. Well, this is 5 over 5, right? 5 plus negative 3 is 8. So we have 8 over 5 over 2, which we can now change into negative square root of 8 over 10. We can at least change a couple of these. We can do is multiply both top and bottom by 10 to get negative square root of 80 over 100. This allows me to have a perfect square in the denominator, so I can put 10 out here. And if we were to reduce the square root of 80, well, perfect square is 4, so we'll put that 2 out there. And 4, leaving 20. I don't like what I did there, guys. Hold on. Let me see. Calculator. I did 80 divided by 16, so I have a perfect square there. So that gives me 4 square root of 5, and then we can reduce that even to negative 2 square root of 5 over 5. One more, and this is our verifying, guys, so take it step by step. We are going to start here, and it would be easier to change the left side. We are also going to convert the theta into a half angle. Okay, so we have sine 2, but theta we're looking at as a theta over 2, because that's what we're identifying tangent as equals 2 tangent theta over 2 all over 1 plus tangent squared theta over 2. Okay. We're going to kind of manipulate this side here because this is sine. Now, I can change. Here's an identity down here. We have 2 tangent theta over 2 all over secant squared theta over 2 because that's our identity, our Pythagorean identity. Now, secant squared is the same as 1 over cosine squared. So I'll write that down so you guys can see it. But in the long run, when we are dividing by a fraction, it's the same thing as multiplying by the reciprocal. So we end up having 2 tangent theta over 2 times cosine squared theta over 2. This is a power reduction formula, so this is new. It's hard to actually recognize that. We get 2 theta, or 2 tangent theta over 2. So this would be 1 plus cosine 2 times that theta all over 2. This is nice because these two cross off. Let's see, let's bring out, if you look here, let's see, we've got 2 tangent theta over 2 if you look now, I can divide this up into 1/2 plus 1/2 cosine theta. I can then bring a 1/2 out front. Leaving 1 plus cosine. So this 2 and the 1/2 cancel. If you look, this was sine theta, correct? So if I'm trying to get tangent theta over 2 by itself, because I was starting here, it's multiplication, so I would divide. I get sine theta all over 1 plus cosine theta equals tangent theta over 2. And what do you know? This is exactly what we were trying to find here. So what they did, guys, again, they started with this identity and we changed it into this. Okay, and that's all you have. So now you're going to practice with the reduction formulas and the half angles. This is your last part of 10.4.